In this video, we're going to talk about how to solve an equation that contains a radical. A radical would be a type of root, a square root, a cube root, anything similar to that. So I've listed some steps that you could use here to solve. The first step is to isolate a single radical. So if there are more than one radicals, two square roots, say, in one equation, then you would just choose one and isolate it or get it by itself. And then we're going to raise both sides to an appropriate power. A power and a root are opposite operations. So when I have a root, if I want to remove it, I need to apply a power to both sides. If I have more than one radical, then I would maybe need to do that set of steps more than once. We're actually not going to look at those today or this semester, but this set of steps would apply if that were the case, right? We may need to do steps 1 and 2 multiple times. Once we've removed the radical, then we're going to solve the resulting equation. I'm going to show you a couple different types of examples so that the step 4 may look different depending on the question. And then it's very important for these that we check our answers because we could get what are called extraneous solutions or extra solutions that look like they work, but when we go back to check them, they actually don't work. Okay, so just a few examples to help you understand how these steps work. So we'll start with this one. We have the cube root of 4 minus x equals 3. I already have the cube root by itself on the left-hand side, so that's the first step. Then I need to raise both sides to an appropriate power. For a cube root, I want to raise both sides to the power 3 to cancel out the cube root here. Anything I do to one side, I have to do to the other to keep it equal. Okay, and then the cube and the cube root are going to cancel each other out. A power of 3 and a third root, right, those are opposites. The whole radical symbol goes away, and I'm left on the left side with what was inside. 3 times 3 times 3 would be 27. Okay, and now I've removed the radical and I can solve what's left. So I'll subtract 4 from both sides. This negative x is like a negative 1 times x, so I can divide by negative 1 on both sides. Looks like I get negative 23. So then remember the last step here is to do just a quick check to make sure that this one works. To do our check, we always want to take the answer we've got all the way back to the beginning. If we were to take it to some place in the middle here, if we made a mistake, we may not catch the fact that we did make a mistake. So I'm going to go back and I'm going to substitute negative 23 for x. See if this comes out to 3. So this would be the cube root. These two negatives here are going to form a plus, so this will be the cube root of 27 equals 3. You know that's true. So this solution does work. Okay, let's try another one. This one's from your book. So we have the square root of x minus 4 plus 1 equals 5. Remember that first step was to isolate the radical. So we want to get this square root by itself, which means I need to move this 1 over to the other side by subtracting. Then I want to raise both sides to an appropriate power. For a square root, the opposite of a square root would be a square. So the square and the square root are going to cancel each other out. And I'm going to get x by itself by adding 4 to both sides. Looks like I get x equals 20. So again, I just want to check and make sure that that does indeed work. So I'll go back to the top. And plug in 20. Minus 4, that's the square root of 16. I know the square root of 16 is 4, so 4 plus 1 is 5. I'm convinced that works. So x equals 20 is our solution. Okay, I have a third one here for you. This one is same process. But as we solve, it looks a little bit different in the in-between steps. So I thought we could look at this one as well. Okay, so same basic steps. Again, we want to isolate the square root. So we'll subtract 6 on both sides. What makes this one different is I have variables on both sides. I don't just have the variable under the square root like the last example. I also have a variable on the right hand side. And so that produces a little bit different result. But it's the same process. Okay, so the next step is to remove the square root. So we'll square both sides. And since I have 2 parts on the right hand side, I need to put that in parentheses and square it. Okay, on the left, the square and the square root are going to cancel each other out. On the right, I need to use FOIL to multiply this together. So I'm going to write out 2 copies of x minus 6, since that's really what the square implies. And then I'm going to multiply these 2 copies together using FOIL. So the first times the first, the outside would be a minus 6x, the inside would be a minus 6x, and the last times the last would be a positive 36. These are going to be alike, so we can group them together. All right, so here's the part where we've removed the radical, but the equation that we have as a result is a little bit different than the examples we've done so far. Can you see what makes this one different? It's this x squared right here. So the process I would use to solve with an x squared is different if I were to just have x's, right? It's different. So we've been sort of taking some time to look over those strategies. We have lots of 4 actually that we've taken the time to look at in the last few weeks of class, right? So different ways to solve with an x squared. We've talked about factoring, we've talked about the square root method, the quadratic formula, completing the square. Okay, so those are sort of the strategies you want to think about and choose from. Usually factoring is the fastest, so I'd like to try that first. If we think about the process we use to factor, the first thing we have to be concerned about is we need to have 0 on one side. So that's the next step, is to get 0 on one side. Since I just have one term over here, I'm going to move the x over to the right hand side by subtracting. And then I'm really hoping that this is factorable. I like to try factoring first because usually it's faster. If I got stuck, then my personal preference is to fall back on the quadratic formula. Completing the square would also be a good choice. Okay, so I need two numbers that multiply to be 36 and add to be negative 13. I'm thinking 9 and 4 might work with two negatives. Okay, so the last step here, if I set each of those equal to 0, I'm going to get two possible answers. Four and 9. And now, just like all the others, I want to check each of these to make sure that they work. It's an individual check. So I check 4, see if it works, and then separately I check 9, see if it works. Okay, and I'm going to go all the way back to the top. So let's start by checking 4. So we're going to put 4 in everywhere where there's an X and see if that works. So the square root of 4 is 2. 2 plus 6, does that equal 4? I don't think so. Okay, so 4 is out. 4 would be one of those extraneous solutions that doesn't actually work. Okay, so now let's do the same thing for 9. Does 9 work? 3 plus 6 equals 9? Yes, 9 works. Okay, so x equals 9 is our only solution. All right, well, I think these examples will give you a good start to learning how to solve an equation with a radical. I hope you'll take some time to practice these at home. Good luck.